So we started doing some free throw percentage problems in the last video, so let's continue. So in the first time I said, well, if I have an 80% free throw percentage, what are my chances of getting 3 free throws in a row? And I said, well, it's 51.2% chance. Well, let's do another scenario and let's just assume that my free throw percentage stays at 80%. And let's say that, I don't know, let's say there are two, let's say my team is 2 points behind. I'm making this up on the fly, so we're 2 points behind. 2 points, no, let's say we're 1 point behind. 1 point behind. We're 1 point behind. And I'm up at the free throw line, and I want to say, what is the chance? And let's say I have 3 free throws. So, someone fouled me when I was shooting a 3-pointer. So we're 1 point behind. There's 1 second left. 1 second left. And right when I was going to take the winning free throw, or not the winning free throw, the winning 3-point shot, someone fouls me. So I get 3 free throws. So I get 3 free throws. And once again, I have an 80% free throw percentage. My actual percentage is probably something more like 20%. But anyway, I have 3 free throws. So my question is, what are our chances of winning? What is the probability of my team winning? Winning, not tying, winning. So in order to win, well, actually, let's do the tying first. So what's the probability of tying? Tying, or tie? How do you spell tie? Tying. Okay. What's the probability of a tie? What's the probability of tie? Well, the probability of a tie is going to be equal to the probability of me getting at least one one free throw, right? You would say, oh, well, I have to say, okay, that's the probability of getting exactly 1 times the probability of getting 2 out of 3 times plus the probability of getting 3 out of 3. But like we saw in, I think it was either the last video or the video before, that is identically equal to the probability, or let's say 1 minus the probability of not getting any free throws, not getting any free throws, right? It's the probability of getting at least 1 is essentially the probability of me not missing all 3, right? Hopefully that makes some sense. So let me erase all this stuff that I did up on top, and we can figure out the answer to this problem. So let me erase all of this. Let me erase all of that. Erase that. Let me erase this. We know I have an 80% probability of making any one shot. So if we go back to the problem, so this is my free throw percentage. Free throw percentage. So what is the probability of me not making any shots? Not making any of my free throws. Well, my probability of not making 1 free throw is 20%, right? 20% chance not making any free throws. Or not making any, say I take a shot, I have a 20% of no basket. Or not making the free throw. So if I'm taking 3 shots, the shot of I miss all 3 is going to be equal to 20% times 20% times 20%. Right? And that equals what? This 0.2 times 0.2 is 0.04 times 0.2, right? And then, let's see, what's 0.04 times 0.02? Let's see, that'll be a 8. And I have 1, 2, 3 numbers behind the decimal place. It's 1, 2, 3. So 0.008. So I have a 0.008 chance of missing all of the free throws, right? Or another way you could view this is equal to, right? A percentage is just this times 100, so there's 0.8% chance of missing all of the free throws. Or another way of viewing this is so what's my chance of making at least 1? Well, it's going to be 1 minus this. So what's 1 minus point? This is a 0. 0.008. Well, it's 99.2%. Right? Yeah, that's 99.2%. Right, 99.2% chance. Or you could also use 0.992. Right? You take 1 minus this, you get 0.992, which is the same thing as 99.2% chance. So I have a 99.2% chance of at least tying the game. So it's pretty high if you have someone at the free throw line with a 80% free throw percentage and they have 3 shots. Now, what if I only had 2 shots? Let's say I got fouled when I was taking a 2-pointer and I only have 2 shots. Well, in that case, in order to tie the game, I have to get at least 1, but I only have 2 shots. So it would be 1 minus the chances of me missing both shots. And what's the chances of missing 2 shots? Well, the chance of missing 2 shots in a row, I have is 4%, right? 20% times 20%. So 4% chance of missing 2 shots, 2 in a row. So my probability of getting at least 1, assuming that I am taking 2 shots, is going to be 1 minus this. So I have a 96% probability of at least 1 shot if I take 2. So that's also pretty high. And of course, what's my probability if I only have 1 shot? Well, it's 80%. So hopefully that gives you a little bit of framework next time you watch a basketball game, and you can pause your TiVo and figure out the probability at, when the person is making that last clutch shot, and it could be an interesting experiment for you. Anyway, so let's. And actually, I was thinking an interesting scientific experiment, or maybe a high school science project. People have a free throw percentage, and that kind of implies that every time someone takes a free throw, that those are mutually exclusive events, that they are independent of the previous time, like we said with coins. But an interesting idea, in basketball, people always say, he's hot now, or he has a streak. And so there is this notion, and I know I felt it, that there are times that your probability increases or decreases, and it tends to be maybe dependent on whether you made or missed your previous shot. So one thing you might want to, this is, I think, a legitimate science project, is to either get the data from real NBA players and see if they really are mutually exclusive events. If the probability of making the next shot or the next free throw really is independent of whether they made or missed the previous one, or whether it actually is dependent. Or if you don't have all the data from the NBA or wherever, although I suspect you could find it, you could try it with yourself and your friends. Or maybe since you want to be unbiased, you'll do it with your friend. You'll see if the probability of them making the next free throw really is independent of whether they made the last one. Anyway, I think that could be quite good, and you can get quite involved in the analysis. So let me finish this up with another scenario. We talked about free throws. We talked about flipping a coin, and now I'll talk about dice, because that is really another area where, it's one interesting, and you'll probably see some problems on probability. So in general, when you're playing games involving dice, it's always interesting to say, what's the probability if I have 2 6-sided dice? What's my probability of getting, I don't know, a particular number? Let's say, what's the probability of getting a 7? So to think about that, you have to say, well, what has to happen for the dice for me to get a 7? And I think here it might be interesting to draw a bit of a grid. So let's say that's my grid. Let me split it up into 6. So let's see, that's splitting it up into 1, into 2. And each of these need to be split up into 3. So it'll be like that. It won't be perfect, but close. Like that. Like that. And like that. And let me split it. So you'll see what I'm doing in a second. Actually, I didn't want to do that. Well, that's good enough. Let's do this. I'm trying to make it a 6 by 6. Okay. And the reason why I'm doing this is because let's make this top axis, this horizontal, each of the situations I can get on the first dice. Right? Although we're going to roll them simultaneously. Although it doesn't matter if I roll them simultaneously or one after the other, or I roll 1 dice one after the other. So on this first dice, I could get 1, a 2, a 3, a 4, a 5, or a 6. So this is dice 1, D1. And on the second dice, I could get a 1, a 2, a 3, a 4, a 5, or a 6. And this is dice 2. And I'm running out of time, so I will see you in the next video.